Okay. If you're coming into this course having taken 1324, which some of you may not have had 1324, but that's the first half of this book, and it ended with chapter 11, which was limits. And so the assumption is that you have a fear. Oh, that's a good word. You have a feeling for limits. We're not going to cover them. If you didn't have that and you feel like you need to look back, you can go electronically, look at chapter 11, look through it, because there are a few things that you're going to need when we get started. But we're going to assume that you know that. And we're going to start right out with derivatives on chapter 12. Okay? All of this here is, hold on. I need my little, okay. All right. On the first line, notation for derivatives. So you're going to see different ways in that first line of red. F prime of x, that means derivative. dy dx. You might see the last two if you were looking in the book. I don't usually write them that way. I tend to write f prime of x or dy dx. So you will see that. Okay, so just to let you know, those are the ways that you might see derivatives. The next thing begins our rules. Constant rule. If f of x equals k, that means like y equals 3, y equals 7, some number, then the derivative is 0. The rule is the derivative of a constant is 0. So when you're taking derivatives and it's a long polynomial, if you come to a constant, its derivative is 0. The examples are listed there. F of x is 8, the derivative is 0. G of x is pi, 0. Y equals 2 to the e. 2 to the e, e is what? What is e? Yeah, it's just a number. Okay, e is just a number. So 2 to the e, the derivative is still y prime equals 0. Does that make sense? That's an easy rule. Okay. Oh, whoa. I don't know what that was. We're just going to ignore it. And I'm so glad that dot just decides to do that. That'll be great. All right, power rule. Let's put that one up there. F prime of x, if you have x to the n, so something to a power, then the derivative is the power times x, and then you take 1 away from the power. You don't have to get caught up in memorizing this. No, it just comes right there and it won't go where it's supposed to. Bring the power to the front, take 1 away from the power, and that's the derivative. So if we're looking at y equals x to the 6th, y prime is 6x to the 5th. What happened? The 6 went to the front, 6 went here, and we took 1 away from 6, so that was 5. So 6x to the 5th is the derivative of x to the 6th. X to the 4/3. Okay, we bring 4/3 to the front. We take 1 away from 4/3. So you've got to think of it as 3/3. So 4/3 minus 3/3, 1/3. So you have 4/3 x to the 1/3. Z to the 1/2. If we're taking the derivative of that, 1/2 goes to the front. We take 1 away from 1/2, and it becomes negative 1/2. You're always taking 1 away. Okay? Now, on the 1/2 z to the negative 1/2, that could be written 1 over 2 z to the 1/2. What happened there? Why did that go to the bottom? What, Liz? Right. Negative exponents indicate a change in position. So if it's a negative 1/2 and it's on the top, to make it positive, it goes to the bottom of the fraction. Or you could go ahead and make that square root of z, because z to the 1/2 is the same as the square root of z. Calculus doesn't kill people. It's the algebra that they've forgotten that kills them. So, keep up on the algebra as well. All right, any questions on those? That's a real basic rule. When you're taking the derivative, oh, what is doing? I don't know what's happening. Do what? Oh, thank you. I didn't read that. You read that. You had time to do that. Well, we'll see if this works. If it comes back up, thank you. I'll read that part of it. All right, any questions on that rule? Okay. All right. There's some application rules, and the red is the derivative of those things. So if you have a cost function, usually it's C of x, and so marginal cost is the derivative of that function. That would be C prime of x. If you have a revenue function, marginal revenue is the derivative, R prime. And the same thing with profit. And I wrote in there that profit was revenue minus cost. Okay. So those are your economic applications. And then there's some scientific applications. If you've had physics, then you've dealt with position, velocity, acceleration, and calculus helps you do that real easily. Velocity is the derivative of the position, and acceleration is the second derivative. So you can get those written down, and we will go from there. While you're finishing that up, because we're going to be heading to the problems, that packet that you picked up is the problems that we're going to work in class for lecture. And they are printed from a set of problems right out of MATLAB, at least printed a while back. So the problems have regenerated, but these are going to be just like the ones that you will see. And what my goal is that not only do you have a way to work them, but you know what format MATLAB's going to expect. That's the bad thing. That's the only bad thing that I see about MATLAB, is if you were giving me an answer and you had square root of x, I would take that, or I would take x to the 1/2. MATLAB has a certain way it wants the answer. Sometimes you'll have a feel for that, sometimes you won't. But my goal is when we do the problems in class that we're going to do for preparation, I already know what format usually it needs, and so I'm going to point out this is what you need to do for MATLAB. I mean, you can watch an example and you'll know what it's supposed to be, but hopefully we're saving you a step. Everybody good? Okay, so we're going to go to the packet of problems, and we're going to start with that section 12.1. Those of you that got a stapled packet, I apologize for that. I asked them to hole punch it, thinking you could put it in a binder. And I never said staple, and I don't know why anybody would think you would staple with hole punches. I just don't understand that. But I had some extras run, and I wrote at the bottom, please do not staple. So if you can take that staple out, it'll be really good for your binder, and then you're good. You can write all over it, or you can write on your notebook paper, whatever you want, but you have all the problems. Occasionally, I've come across the fact that since I did that, I've decided to take a problem out, and so I'll let you know when we come to that. All right, I'm going to move back over here and go to the problems. Okay. We'll go here. All right, so the first problem, do I need to make that a little bit bigger for you guys in the back? Is that better? Okay. And feel free to tell me when you can't see something, because I'm looking at it here and I don't always get to know what we're looking at. Yes. That one, I've got this one off. You want that one? How about if we just dim it some? Would that be? Everybody, or can you see it? Does that help? It's like being being in a dungeon. Okay. All right. I've got some lights on my stuff. Okay. All right. So we've got a polynomial. We're going to take the derivative of it. Do that in red. Okay. So each piece we can take the derivative of. If we have x cubed, what's the derivative of x cubed? 3x squared. Okay. Minus 32x plus 45. And what's the derivative of 2? 0. Okay, so that's easy enough. We always start out easy. Any questions? We took the derivative of each piece. Easy, easy. Okay. If you've already had calculus, you're going, oh, I know this. This is good. All right, number 2. And the thing that's different is you see a fraction in the middle of that polynomial thing. And so I would say to rewrite it, and rewrite it as x cubed minus 1 over 64 x squared, so that the number is all out to the front. That's going to make it easier for you to see to do the derivative. Okay, so rewriting it would be the first thing that you would want to do. All right, so let's take the derivative of that. Derivative of x cubed, 3x squared. What's the derivative of this? Is that 2 over 64, which would be, reduce it, 1 over 32. What's the derivative of that one? 45, and we've got that. Now, for Math Lab, they want you to go back to the form that was in the original. So they don't want 1/32 out in the front. So they're going to want it like this. Okay. Yes, sir. Oh, yeah, it should. Thank you. Is that what you were doing, Meg? You were wanting to raise your hand. You have to catch me. Okay. All right. Any questions about that? This is the way you'll probably want to do that for Math Lab. Yeah, I would. His question was on the test, would I take either way? And yes, I would. Okay. All right. This one has negative exponents, 5x to the negative 6 minus 4x to the negative 1. And so we're going to do the same thing. What will be this part here? What's the derivative of the first part? Negative 30x to the. Now take 1 away from negative 6. Negative 7. Okay? And then note that you're multiplying negative 1 times negative 4, so this changes signs. 4x to the negative 2. So be careful with that. Little things like that, the signs can mess you up. Okay? Any questions on those? Okay. Number 4 is written as fractions with x squared being on the bottom and x being on the bottom. So I would rewrite it with negative exponents. That makes it easier to just do the rule like we know the rule. Okay? So when you rewrite it, then it makes it pretty easy. What's the derivative of 5x to the negative 2? Negative 10x, yeah, plus 9x to the negative 2. Okay. And then since this original was in that form, that's a pretty good hint that the Math Lab is going to want it back in that form. So for your final answer, what would it be? It would be negative 10 over x cubed plus 9 over x squared. Okay. Questions? Anybody? Okay. So really, you definitely want to rewrite things to make it easier for yourself to do that. Okay. Number 5, is that not the problem you have, or is it? It is? Okay. I knew I changed something somewhere. All right, y equals -5 over the cube root of x. Well, just to make it easier, you want to make it, number 1, not a fraction, and then use the negative exponent so that you have just this one line, no radicals, no nothing. Then it should be easier to write the derivative. So -1/3 times -5 is 5/3 x to the negative what? -4/3. Now, on this particular one, I think MATLAB wanted it in that form. That's not the usual way it works, but I think that's what I had down. So they'll let you leave it in that form. Okay? If not, how would you change x to the -4/3 to something with a radical and without a negative exponent? It'd be 1 over what? Cube root of x to the 4th. Absolutely. The bottom of the fraction becomes the index of your radical. Okay, that's the index part. And the top is the power that's inside. Okay. All right. Now, this one, h of x equals x to the 10th minus 2, all of that cubed. If you've already had calculus, you're thinking of another rule that we don't have yet, so we're doing this the long way. So that's what we're going to do, and you'll just have to bear with me. All right, so something cubed means you multiply it by itself 3 times. So that's what I wrote on the rewrite line. And then you need to go ahead and multiply these two guys together. So when you multiply x to the 10th times x to the 10th, what do you get? Algebra. X to the 20th. You add the exponents. So you get x to the 20th minus 4x to the 10th plus 4. Now, looking at that, make sure that you see what I did. When you multiply, you just add the exponents. I had a minus 2x to the 10th and another minus 2, so that became minus 4. Then I've got to multiply this guy times the red one. Okay? So take x to the 10th and multiply it by every term there. You should get x to the 30th minus 4x to the 20th plus 4x to the 10th. That's the first term multiplying. Then you have minus 2x to the 20th plus 8x to the 10th minus 8. So I just took each term and multiplied it by that. Because right now I'm still just rewriting. I haven't even begun to take the derivative. So I can simplify a little bit. What do I get? I get x to the 30th minus 6x to the 20th plus 12x to the 10th minus 8. And now I'm ready to take the derivative. Oh, yeah, thanks. Keep me honest here. All right, so what's the derivative of this thing? 30x to the 29th minus 120x to the 19th, not 19th, yes, 19th, sorry, plus what? 120x to the 9th, and then the 8 is 0. Since MATLAB doesn't usually have you put it in steps, if you know what you're doing, and you know that rule that's coming a little bit later, and you can use it, you don't have to do all this. You can do that chain rule. How many people have had calculus in here? Had it in high school? I know you guys did. Okay. So, if you know that rule, feel free to use it because it's not going to ask you about steps. Okay. All right. this one gives you f of x is equal to x to the fourth minus 17x squared plus 16. And it says find the slope and the equation of the tangent line at x equals -1. This was all discussed in chapter 11 of this book about the tangent line and that the derivative is the slope. So all they're doing is kind of pulling that in and saying, okay, now you know how to find the derivative pretty well of these basic ones. Let's find the equation of a tangent line. All right? So you want to remember that slope is derivative. That's important. Every time it says slope, you need to think, oh, derivative. Okay? So what is f prime of x? What is the derivative of that guy up there? 4x cubed minus 34x. Okay? So that's your first step. Then it said at a particular point, at x equals -1. They have to give you that because when you have a curve, an x to the fourth, tangent lines could exist everywhere, and the slope would be different at all those different points. So at a particular point, at x equals -1, they want to know the derivative. So you need to find f prime of -1. That means just plug in -1. Okay. What does that equal? Get your math going. I don't know why I put another thing there. So I circled that because that's an important number that we need to know. When you go to write the equation of a line, what do you need? You need the slope and you need a point. You've got the slope. You've got an x value. What are you missing? The y value of that point. And you need the y value for when x is -1 in the original, not in the derivative. So if x equals -1, y is, you've got to plug it back into the original. -1 to the fourth minus 17 times -1 squared plus 16. So I'll let you do that and come up with a number. What does that look like? Anybody? What number you get? 0. Okay. Yeah. Okay. So we have, that didn't work. Okay, so we have the things we need. We have a slope and we have a point at -1, 0. Now we can write the equation of the line. So I've written the point slope formula right here. Y minus y1 equals m times x minus x1. You need to know that. If you don't know that, you need to know it. And I've written down the parts that we found, 30, -1, and 0, and we're going to plug those into that equation, and that's going to give us the equation of the tangent line. Questions so far on that one? We're just going to plug in. We're going to get y minus 0 equals 30 times x plus 1, because it was a minus a -1. And then we'll clean that up a little bit. It'll just be y equals 30x plus 30. And that is going to be the answer. So we found the derivative of the original, and then we plugged in the x value. That gave us the slope. We took the x value they gave us, plugged it in the original, got a y value, and then we used that equation for the point slope. Questions on that? Okay, good. Can we move? And you know, if I'm moving on and you're still writing, you still need something, let me know, because if not, I'll just keep moving. All right, number 8 gives you this big equation, and says find where the tangent line is horizontal. What do you know about the slopes of horizontal lines? For a y=, line, what's the slope of that? 0. Slope of a vertical line is undefined. Slope of a horizontal line is 0. So we needed to know that. All right. And I just had that up here, so you shouldn't get it. All right. So we're going to find the derivative, and we're going to set it equal to 0. That's what we have to do. So let's find the derivative of that top thing. Put that down a little bit. So find the derivative. Well, I can't get it right there. Okay. So what's the derivative of that? 6x squared plus 72x plus 192. And then we're going to take that derivative and set it equal to 0. Okay? If I were going to factor that, I would definitely want to factor out 6 before I started factoring it. So if you take 6 out, the 6 is going to disappear, and we're just going to factor this. So how does that factor? Mm-hmm. Those are the two places where the tangent is equal to 0. That's where the tangent line is horizontal, because the slope is equal to 0 at those points. So that's your tactic for that one. Find the derivative, set it equal to 0, solve for the x values, whatever they are. That'll be your answers. I think we have, what, just a couple more? They're not bad, I promise. Okay. Everybody okay with that? Okay. All right. Number 9 gives you a position function, and then it asks you a few things. I think it asks you for the velocity. And remember, we wrote down that velocity was the same as the first derivative. So v of t is the same as s prime of t. So we'll just take the derivative of that thing. What's the derivative of that? Anybody? What's the derivative of this one? Well, I'm pointing and you're not seeing. Hello, wake up. What's the derivative of 19t squared? 38t. I was determined somebody was going to say it. Minus what? 14. Okay, so that's going to be the first blank that you have to fill in. They want to know the derivative. Okay. And then the rest, if it says v of 0, what are they asking you to do? Plug in 0. So you're just going to plug in the numbers that they're asking you in b for t. So what will the first one be? Negative 14, because the t goes away. V of 5, and I'm going to let you do that. If you have a calculator, or if you can do it in your head, or whatever, and see what number you come up with. And you will need a graphing calculator throughout the course. If you have a T89, that's fine. 83, 84 is what I'll use. So you will need one. Well, it'll be to your benefit to have one, I'll put it that way. All right, so what number did we get? What? Okay. 176. And then V of 9. And I have a few calculators up here if somebody doesn't have one and needs one today. All right, so that's not bad. You find the derivative, plug in the numbers, you're good. Everybody okay with that? Velocity is the first derivative of the position. Okay? All right. Now, number 10 has some other things. Gives you a position function and says velocity 1 second after dropping. 1 second after dropping. Well, what's the first thing we need to do? We need to find the velocity function. What's v of t? That means take the derivative of that guy. Negative 32t. And so velocity after 1 second has dropped would be what? That's v of 1. Negative 32. Why do you think it's negative? Dropping. Heading down. Okay. All right. When will it hit the ground? When will it hit the ground? What you need to think about, if it's hitting the ground, what's its position then? 0. Okay, so if we take that original thing that we had, negative 16t squared, plus 155, and set it equal to 0, and we solve that, we should get something. This is where your calculator would be helpful. I think I left myself a box for that. Because you're taking the square root of 155 over 16. And does the packet say round it to the 10th? Is that why I did that? Okay. All right. So set it equal to 0 and solve for t, and you should get when will it hit the ground? That many seconds. So after 3.1 seconds, this thing is hitting the ground. That's not derivatives. That's just physics and algebra. All right. Then the C part says what? What is the velocity upon impact? So that's saying v of what number? V of 3.1. Because that's how long it's going to take us to get there. So what is the velocity when we're hitting the ground? So that means you're going to find v of 3.1. So that's negative 32 times 3.1, which is negative 99.2. And there's some measurements with that. That's feet per second or whatever that is. I'm not worried about that right now. It usually has that in MATLAB for you. If it were physics, I'd probably be picky about that, but I'm not. Questions? Anybody? Those are the problems that you're going to have on MATLAB for section 12.1. We've worked them just like they are. You know the format. You know what it's expecting. Okay? So I'm going to stop my recording here. I don't need that. And I don't need that. I need that guy.